In 1927, two Scotsmen sat down with the death records of the Bombay plague and asked a question nobody had answered, not why epidemics start, why they stop. The plague had faded while most of the city was still healthy. It had not run out of people. William Kermack and Anderson McKendrick found the answer in 3 letters and a handful of arithmetic. SIR, susceptible, infected, recovered. Watch what those 3 letters do. The model is almost insultingly simple. Everyone sits in one of 3 boxes, and 2 numbers move them. Beta, how fast the infection jumps between people, and gamma, how fast the sick get better. Divide one by the other and you get the most famous number in epidemiology, R0, the number of people a single case infects, in a world where nobody is immune. Above 1, it grows. Below 1, it dies. Everything else follows from that. "700 people. 3 of them are sick. Beta and gamma give an R0 of 3, roughly the original strain of COVID. Every dot is a person, walking, meeting, infecting. Blue is susceptible, red is infected, green has recovered. Nothing here is scripted. The curves on the right are drawn by the dots on the left. And now watch closely, because here, this is the part nobody expects. The epidemic is slowing. It is stopping, and it stops having infected 87% of them, which means 90 people, still blue, never caught it at all. Nobody protected them. Nobody locked anything down. So what stopped it? Look at RE, the effective reproduction number. It starts at 3, exactly like R0, because everyone is susceptible. But each person who recovers is 1 less person left to infect. So, RE falls. Not because the virus changed, not because anybody changed their behavior, simply because the fuel is running out. And right here, around day 44, RE drops below 1, and the curve of infections turns over. That is the peak, not a policy, not a season. An epidemic dies at its own success, having burned through the very people who carried it. Now change 1 number. This is measles, R0 of 15. Same crowd, same rules, the same 3 sick people. But 1 case now infects 15, and the fuel does not run out in time. Watch the blue disappear. Not 87% this time, 100%. Every single person. And look at the threshold the model computes. To hold RE under 1 from the very first day, 93% of this crowd would already have to be immune. There it goes again. Measles through an unprotected crowd. Now let's give it exactly what it needs. 94% immune before day 0. Same disease, same beta, the same 3 infections to start it. But now, every sick person is surrounded by people who cannot pass it on. RE begins at 0.77, and the outbreak never starts. 0.9% infected, and the unvaccinated among them protected by everybody else. That is herd immunity. Not a metaphor, not a slogan, but an inequality written in 1927 that you just watched a crowd obey. The link is on screen. Set your own R0, move the vaccination slider, and find the exact point where the outbreak stops being possible. This was SimSciences. Subscribe and we'll keep turning the laws of nature into things you can reach out and touch.